In this video, we'll be learning how to use the sine rule to find unknown angles in a triangle. Now, to begin with, let's just quickly remind ourselves of the formula we'll use when looking for unknown angles. So let's say we're given this generic triangle, and that we label its vertices with the name of the angle, the interior angles, and so we'll go ahead and say capital A, capital B, and capital C. Remember, we always label counterclockwise. We now label the side lengths, and these are labeled in the lowercase letter of the angle that they're facing, that they're opposite to. So the side length opposite the angle A will be labeled lowercase a. The angle the side length opposite the angle B will be labeled lowercase b. And last but not least, the side length opposite angle C will be labeled lowercase c. There. Now, when we're looking for unknown angles, we'll be using the sine rule written in the following way. We'll say that the sine of the angle A over the side length A is equal to the sine of the angle B over the side length B, and that is equal to the sine of the angle capital C over the side length C. Now, to use the sine rule to find unknown angles, we'll always need two bits of information. We'll always need, so I'll just write we'll need, first thing, one side length and this is very important, and its opposite angle. So even though those are two pieces of information, I tend to put those together because it's very important when using the sine rule to think of side lengths and their opposite angles. Think of them as pairs of information. So we'll need one side length and its opposite angle. And the second thing we'll need is the side length which is opposite the angle we're looking for. So you may want to make a note of that. When we use the sine rule to find unknown angles, these really are the two bits of information we'll always need. So let's go ahead and look at an example. Let's say we're given the following triangle. And that we're told that this side length is 4, that this side length is 6, and this side length is 5.7. We're also told that this interior angle is 40, and we're asked to find this interior angle A. Okay, now, let's see if we can use the sine rule here. Remember, to use the sine rule to find an unknown angle, we need one side length with its opposite angle, and we need the side length which is opposite the angle we're looking for. So looking at this, we can see that we have one side length 4, and we definitely have its opposite angle, which is 40. So that's the first box checked, if you wish. We have a side length 4, and its opposite angle 40. Second important thing is, we're looking for the angle A, and we have the side length which is opposite it. So we have the length 6, which is opposite the angle we're looking for. So really, this fits the criteria. We can definitely use the sine rule. And to find the unknown angle A, we can go ahead and write sine of A over 6 is equal to sine of 40 over 4. We can now rearrange this. If we multiply both sides of this equation by 6, it'll turn into sine of A is equal to 6 times sine of 40 divided by 4. Now, if we actually calculate this, we'll find that sine of A is equal to 0.964181. And now, to actually find the angle A, we use the inverse sine function. And we write A is equal to the inverse sine, which we write like this, of 0.964181. And using our calculator again, of course, and rounding to one decimal place, we find that A is equal to 74.6 degrees. And there you go. We have just used the sine rule to find an unknown angle inside our triangle. And if we wish to, we can complete our diagram. Remember, we had a triangle looking something like this. We were told that this side length was 5.7, this side length was 4, this side length was 6, and we were told that this interior angle was 40. And using the sine rule, we have just found that this interior angle is 74.6 degrees. And there we go. Let's look at another example. Let's say our triangle looks something like this. And that we're told that this side length is 7, this side length is 8, and this side length is 5.3. We're also told that this interior angle is 80 degrees, and we're asked to find this interior angle, which we'll call x. So again, we need to stop for a second and figure out if we can actually use a sine rule to find this unknown angle. Now remember, at the very beginning of this video, we saw that to find angles with the sine rule, we'll always need a couple of things. We'll need to make sure that we have a side length and its opposite angle, and we need to make sure that we have the side length which faces, or which is opposite to, the angle we're looking for. So looking at this, we can see that we're given this side length 8, and we're given its opposite angle, which is 80. We can also see that relative to x, which is the angle we're looking for, we are given the opposite side length, 7. So this is looking good. We can definitely use the sine rule here. And we can go ahead and write sine of x over 7 is equal to the sine of 80 over 8. And if we multiply both sides of this equation by 7, we can rearrange this to write sine of x is equal to 7 times sine of 80 over 8. If we calculate that right-hand side of the equation with our calculator, we'll find sine of x, without any rounding for the moment, is equal to 0.861707. And so, to find x, we're going to use the inverse sine function, also known as arcsine. And we're going to say that x is equal to the inverse sine of 0.861707. And so once again, using our calculator and rounding this to one decimal place, we find that x is equal to 59.5 degrees. And there we have it. We've just found an angle again using the sine rule. And for the sake of completing the diagram or triangle we were given, we had something looking like this. We were told that this angle was 80 degrees, this side length was 8, this side length was 7, and this side length was 5.3. And using the sine rule, we have just found that this interior angle facing the 7 is 59.5 degrees. And there you go. I hope that helps.